Okay. So I think in last session, I was explaining about the Hadoop introduction part. So why the Hadoop came into the market and who started that one, and what are all the different features are what is that language we have to use to to process the data, and when was it started? All those things we understood, right? Okay. So like uh, where does actually data stores in Hadoop? Come on, help me. So in Hadoop, where are you storing the data? HDFS, Hadoop Distributed File System. I told you right already. So you are instead of processing the data with a single computer or a single system, you're going to process the data with multiple systems parallelly. That too. Okay, and the data will be stored. That means not physically. I can say like logically the data will be divided and it will be stored it in the hard disk of the each system that you have in the Hadoop. Okay. Data will be stored in the HDFS. Okay. What is that programming language we used to use for processing the data in Hadoop? MapReduce. MapReduce was the program. So in order to write the MapReduce program, what is that language we have to use? Java language we have to use. Okay. So if this is the input, actually, we have to write the code for map and we have to write the code for reduce and we have to get the output of for that. Okay. So we used to write the code like this. Okay. Now, uh, what are all the disadvantages or are the drawbacks of the Hadoop? That's what we need to understand first. Okay. In Hadoop, actually, we have already for batch processing, Hadoop MapReduce programming is there. And for stream processing, streaming data, okay, Apache Storm was there. And for interactive processing, either Impala or Tej was there. So, I mean, why I'm trying to introduce all these words is sometimes once you get into the real time, right, you will hear these kind of words actually. I mean, nowadays, no one is using Impala and Tej. I mean, it was 5 years back story or 6 years back story, I can say. Okay. So, but it used to be there actually. So, for interactive processing, we used to have Impala and Tej. And for graph processing, actually, Neo4j and Apache Giraffe was there. Okay. All these things were there and they used to satisfy the industry requirements as well at that time. But what happened? What are all the disadvantages? Why Spark came into the market after some time? Okay. So the reasons are even though MapReduce was solved the problems that industry was facing long back, okay, still MapReduce is not good for programmability. I told you already, the people who are on the data engineering side, especially, they know mostly SQL. They don't know actually the Java and all. Most of the data engineers have good knowledge on the SQL, not on the Java. But at that time, because of the Hadoop, people has to learn Java and people has to switch their technology from SQL to like Java, or they have to have knowledge on the SQL and Java both. And that too, number of lines of program for each requirement, right? It was very huge actually. Even for writing, even for calculating the count of records from one table, so we used to write actually 100 lines of code for that in Java. So it's very difficult for people to manage this coding part actually. I would say that this MapReduce was utter flop at that time. Utter flop means people used to feel difficult. Language perspective, I'm telling. Okay. And that to specialized systems for application. Of course, we need to use and we have to have the HDFS, we have to have the cluster, and there we have to install the Hadoop, and there we have to install the DFS, and all those things should be there. That was one of the complex thing actually. So we have to establish the cluster, right? See, even though Hadoop community was giving the free software, and it's very difficult for administrator to manage that cluster. Okay, and that too, and this Hadoop was it is not good for actually iterative algorithms and interactive analysis. That means in Python, actually, once you write the code, okay, in a particular cell, it was giving, okay, you can divide the your problem statement into like a group of step. What I would like to say is, let's say I have a requirement, guys. What is the requirement? Like I have a file. I wanted to read the data from this file, and I wanted to like replace some of the words with, let's say, Hadoop word with Spark. That is my requirement. Now, what you do in Python actually, you write a separate in a shell. You create a function to read a file, and in the next shell actually, and you create this function, and in the next shell actually you call this particular function, and in the next shell you'll write a command to replace that Hadoop with Spark. So that means the commands are interactive here. That means your entire requirement, you're trying to divide it into smaller parts here, and you're interacting with the Python, and you're able to get that, you're able to fulfill that requirement here. But in Hadoop, we did not have that kind of interactive environment. We have to write the entire code and we have to test it. That's it. There is nothing called, okay, we can write half code and we can test it so that it will give the proper output. No, you have to write the entire code and you have to execute it. That's it. That was the problem, one of the problem actually. Okay. And one more problem is iterative algorithms. In 2013 and 14, actually, data science was becoming very famous. At that time, machine learning algorithms, slowly people started like implementing in industry. Okay, predictive analysis and your artificial intelligence it was started in 2012, 13, 14 time. Okay, and most of the machine learning algorithms actually, see, machine learning algorithms, what we do, why do we have to like use those algorithms? For predictive analysis. Predictive analysis means what? We have to give the set of data to the algorithm, and we have to identify the patterns in that one, and we should be able to identify some like next year sales growth and like following year sales growth and all those things. We should be able to predict business analysis. Now, so we have to apply these algorithms on top of data continuously. Okay, that means we have to read the data and we have to like get like some predictive analysis we do. If the predictive analysis is almost like 30% or 40% is accuracy, will test it actually in the machine learning algorithms. So if the accuracy is only 30%, again we have to apply the algorithm on the data. So let's say this time accuracy you got 40%. Okay, again you apply the that algorithm on the data. This time you get, let's say, 70%. So until you get the proper accuracy of this algorithm, you need to keep applying like these algorithms on the data. That means every time you have to read the data from the HDFS location and you need to apply that algorithm, and again you have to do that analysis, and again if that is not meeting, again you have to read the data from HDFS. See, HDFS is what? Hadoop distributed file system. That means where are we storing the data? In a hard disk of the Hadoop cluster. See, every time you're reading the data from the hard disk, right? Hard disk, and again if intermediate results are there, you need to write back. Okay, that results you need to write back to the disk only, right? So that means you're reading the data from the disk and you're writing it back to the disk. So reading data, writing back to the disk is a costly operation, I can say. You'll understand why I'm saying it is a costly operation. Even in our system also, we are reading the data from the hard disk and we are writing it back to the hard disk. So why it is costly operation? I'll tell you that one. Okay, most of the machine learning algorithms are iterative actually. So it used to take more time actually to write these algorithms and get the accurate results, I can say. Now at that time actually, okay, I would say, I'll tell you what I'm trying to say is, see, this is the HDFS location. So for the first iteration, what you will do, let's say you are applying machine learning algorithm here. In the first iteration, you're reading the data from here. Okay. And you have done that iteration and you're writing it back to the like HDFS location again. And again, second time you have like decided to like read that data. Again, you are doing that one. And if any intermediate results are there, let's say you're storing that one on top of the data. Let's say second iteration, you keep on every time reading the data from the HDFS and writing it back to the HDFS location. Or if at all, if you want to like query some data from the HDFS, right? Okay, again, you have to refer back to the HDFS location only here. If you want to run some queries, normal SQL queries, I can say. Okay, so this was the problem at that time, like in 2013-14. At that time, actually, people started thinking, can we do better than this? Okay, now what people started, I mean, the inventor of the Spark or the founder of the Spark, what he thought was, instead of using this HDFS hard disk for reading the data, what if we get this data into the RAM memory first and start using that data every time we want to iterate it, every time if we want to like apply that machine learning algorithm. And what if we do transformations or SQL transformations directly in the RAM memory instead of doing it in a hard disk memory? Now tell me, reading the data from the hard disk is a fast one, or reading the data from the RAM memory is a fast one? Are doing the operations directly on top of hard disk data is easy, or doing the operations directly on the RAM, the data which is there in the RAM is easy?
RAM is easy.
Of course. Then what they thought is, then this is actually they thought. Now, in the first time when you try to read the data, get that data and do that iteration. Next time onwards, you try to store it in a RAM memory. Even when you want to execute the like queries, don't read directly from the HDFS. You try to get the data into you try to store the data into RAM memory of the Hadoop cluster, so that you perform whatever you want on top, transformations, whatever you want, you do on top of it. Then this is the start point of the Spark actually. Then people started thinking actually. Now, at that time actually, they were checking in the industry like, okay, any frameworks or any systems are using RAM for processing the data. At that time actually, RAM Cloud and Piccolo. So this was the one of like these two are the like frameworks actually which process the data with the help of RAM memory. They don't process the data in the hard disk, I can say, through processor. They process the data with the RAM. So they thought of like implementing this kind of like technology, I can say. But there are some drawbacks are there in these frameworks. Then what they have thought is, what we will do is, we'll try to load the data into the RAM memory and we'll make it read only. I'll tell you why I'm stressing this point read only here. You'll understand a bit later. You'll understand why they are thinking, why they are making it as a read only. Because actually your RDDs are immutable. I'll tell you what exactly RDD means. Okay, so can we make it can we store that data in the RAM memory and start processing the data, start applying transformations on top of the data so that I can execute them very quickly, and that I have to make them read only on. Okay, and now at that time actually, these founders of the Spark, they released one paper actually in the market. Okay, you know who is the founder of the Spark? Metai Jaharia. His name is Metai Jaharia. Now he is the founder of the Databricks actually. a co-founder of the Databricks. He handed over that Spark project to the Apache Foundation, and he came out from that Yahoo company and he started a new company called Databricks. Now still he's in LinkedIn actually. If you want, you can go and check this guy actually. He used to post some important updates on Databricks. Okay, at that time, how Spark stores the data? Then people started asking Meta Jaharia, hey, how Spark stores the data in that case? Spark stores the data in the form of RDD. What is this RDD? People started asking question to Meta Jaharia, hey, what is that full form of RDD? RDD is nothing but a resilient distributed data set. Hey, we don't understand what exactly mean by this resilient distributed data set. Can you explain a little bit more about that? Yes, boss. Before I get into that one, now I wanted to say that one point here. If somebody asks you, hey, what is Spark and what is Spark? Then you have to say this point actually. Spark is an open source. Guys, even Spark is also open. Hadoop also open source, right? I told you already. You don't need to pay anything for the Hadoop, which was created by that duck cutting. So it's a free of cost. You just need to go to the Apache website and you can start downloading that one. And you can create a cluster and start moving your data into that cluster. Now, so even Spark also, they made it public. Public means they made it open source, I can say. Open source means you don't need to buy a license here. You can happily go to their website and start downloading that one. They handed over this project to, again, like Apache. And it's an open source and fast in memory. Where are we going to do the transformations actually? In memory, in the RAM memory actually. Okay. And general engine for large scale data processing. What is the general engine? What is the general engine meaning actually? See, Hadoop in Hadoop actually, we used to do all these operations, right? For batch processing, actually, we used to use Hadoop, and for stream processing, for the even machine learning algorithms also, we used to use Hadoop, right? Hadoop, right? Now, you can use all those things actually. You can use all those things. That means you can process batch, you can do batch processing, you can do stream processing, you can implement machine learning algorithms. Everything you can do in Spark. It's a one-stop solution for all your for all the activities which you are doing in Hadoop. It's a common framework for all those requirements, I can say. It's a generic framework, I can say. You know, when Spark released into the market, it was just 300 lines of code. That's it. It was just 300 lines of code. Initially, when it was released. Okay. 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 So it's an open source, and that too, competition will happen in the RAM, and that too, it's a general engine. That means it can able to do all the batch processing, stream processing, machine learning, graph algorithms, whatever you want, it can do that. And for large scale data processing, of course. Of course. Now, what I wanted to say here is, whatever the map reduce programming you guys used to use in Hadoop, now your Spark has become replacement of this one. Now, people are not using MapReduce now. Why? Because MapReduce was actually reading the data from the disk and writing data back to the disk. That means that IO operations, input-output operations were very costly. Now, when Spark came into the market, it was actually reading the data from the RAM memory, and IO operations become less costly. So, and now your Spark is 100 times faster than your MapReduce performance, I can say. then obviously if it is 100 times faster than like MapReduce, people will still go with the MapReduce or still go with the Spark. Obviously, they'll go with Spark only. Now, the entire industry started replacing this MapReduce programming with this one. Shiva, in the MapReduce programming, that's okay. They used to use actually Java language to write that code and all, right? Now, what is that language we have to use here? Like in Spark, guys. When Spark came into the market, Spark, I told you, right? It was just 300 lines of code when it came into the market. You know, in which language they have used like to build this framework? Scala language. Scala. This is also one of the Java language, I can say. I mean, I cannot say it's a Java language. The Scala is actually derived from Java language. But it is easier than Java language, I can say. They wrote this framework actually, these 300 lines of code actually in Scala. At that time, Meta Jaharia told to everyone, to the entire industry, to the market, hey, you guys use the Scala language to process your data. It is quite similar to your Python language only. At that time, people started moving actually to the Scala. I'll come back to this point again bit later. Okay. Now, so Shiva, MapReduce used to get the data from the HDFS location. It used to do batch processing, stream processing, and iterative algorithms, all those things, right? Can Spark do all those things? Yes, boss. Yes, boss. Your Spark actually can read the data from the HDFS location, that is Hadoop distributed file system, and it can read the data from S3 location as well. It can read the data from the Cassandra as well. It can read the data from the ADLS Gen 2 as well. It can read the data from the Google file system as well, GFS as well. That means it can read the data from any of the storage. But MapReduce, it used to read the data only from the HDFS location, right? Now, this is the biggest advantage, guys, with Spark. Spark is a generic language, right? Generic framework, right? That framework can interact with the HDFS, S3, CFS, and your ADLS Gen 2 and GFS as well. But MapReduce, it used to read the data only from HDFS, not from other clouds. Then it became very famous. Okay. Okay. So, you're telling, right? Like, it is 100 times faster than MapReduce programming. Yes, of course. Of course. So, it is faster than your MapReduce programming. And it is scalable, of course, just like your Hadoop, right? So, if at all, if you want, if your data volume is increasing, right, you can add at any point of time any number of systems to your cluster. See, guys, remember one thing. In Hadoop, actually, Hadoop runs on top of cluster, right? Even Spark also runs on top of cluster. Let's say I have actually initially for my data requirements, I have only 4 systems here. Okay, only those 4 systems are enough for me for process my data actually. Now, later, like based on my customer, like my business has become very popular. Now, more customers are increasing. Okay, the more transactions are increasing in that case. That means if my data volume is slowly increasing, at that time you can add at any point of time one more system here in the cluster. You can add any number of clusters, any number of systems or nodes to the cluster. It is scalable, no problem at all. It supports that scalability. How your MapReduce is supporting, same way your Spark also supporting that. Yes, that is also one good thing. Okay, what else it can do, Siva? So it's hard, of course. It is used by almost top companies, guys. In data engineering, most of the companies are using this Spark. Most of the companies. I'm not saying 100% of the companies are using the Spark in data engineering, but most of the companies, 80% of the companies, they use like Spark. I told you, right? Like Spark is everywhere. Even if you take like AWS data engineering, in AWS data engineering, what are all the services we use actually? What are all the services we use? We use Glue, right? We use Glue, right? Glue and your Lambda functions, okay, and step functions and your Redshift, okay. Everywhere Spark is there, and all these services we use like backend engine is Spark only. If we take Azure, okay, ADF built on top of Spark only. Okay, Databricks, of course, it is completely Spark only. Synapse Analytics, it is completely Spark only again. Even in the Google BigQuery, even in the Google services also, data in the Google data engineering also, everywhere Spark is being used. Directly or indirectly in every company, because of these services, actually, Spark is being used. So it has become popular. Okay. So, is it difficult to learn? Spark language is very difficult to learn. No, no way at all. No way at all. Okay. You can write the code in Python. You can write the code in Java. You can write the code in R language. You can write the code in Scala as well. Initially, they used to support with Scala. Now they have given support with all these three languages as well. Why R is introduced here? Like because of the machine learning, artificial intelligence and all, data science related applications. Okay. Hmm. Okay. Summary is it started actually, initially it started in UC Berkeley in 2009. I mean, the project actually started in 2009. Uh, it's fast, of course, general purpose cluster computing system. I told you already that one. What is general purpose? General purpose means it can be used for all the other applications. Of course, it is faster compared to the MapReduce programming, and it is popular for running the iterative machine learning algorithms as well, of course. And you can write the code in all other languages as well, like Java, Scala, Python, R, um, like even other language, SQL also. Nowadays, SQL also. You can add SQL also here. Okay, and it can even read the data from the Hadoop as well. If this is having these many advantages, then what is the point of using still MapReduce programming in the companies? Obviously, they don't use it. Obviously, they don't use it. As soon as Spark came into the market, this MapReduce programming actually completely faded away from the market. It has gone away. After 2015, I don't think so. People were using MapReduce programming. They completely shifted to the Spark because of all these features. Post 2015. Okay. Features we discussed, right? Okay. Now, the conclusion point I wanted to discuss is, before I get into the actual Spark. Now tell me, what is the, how do you, if I ask you to compare, hey, Spark and MapReduce, what are all the points you're going to tell?
Programmatically, MapReduce is very lengthy.
Lengthy, correct. Language we used to use MapReduce in the
Java.
Hadoop actually, but here
Here we can
Scala or
write,
Python, Scala,
yeah,
Python, R or Java, anything you can use. That is the first point. Now, processing location. Where is actually data processed actually? In Spark, actually, data is being processed with RAM, within a RAM. But here, disk operations. because of these disk operations, actually IO rate. IO rate means input output iterations are more. Because of that, it used to take more time actually. But because of this RAM operations, it was taking very less time. And of course, speed point of view, if you compare, Spark is 100 times faster than the MapReduce. And of course, this is slower. Okay. And latency means your even speed, kind of speed only. Okay. Latency is very less and it is higher. Input output latency, I can say. Okay. It is lower and it is higher. So computation, iterative computation is possible. Single computation is possible. Okay. And task scheduling, and this is not required actually. I'll discuss about this one like once we complete the understand the architecture point of view, architecture point. Okay. Now, are we good with the comparison? I mean, are we good with the how Spark introduced and who started that, and like what are all the disadvantages in the MapReduce and why Spark has become very famous? Did you understand all those points now?
Yes, Shiva.
Yeah. Any questions so far? Okay. Now let me start the Spark architecture. Guys, this is very important one. Please try to concentrate on this one because in the certification exam actually, almost 20 to 30% of the questions you will get from this architecture diagram only, the which I'm going to discuss in next 30 minutes, for 30 minutes. Okay, 20 to 30% in the certification exam. It's very easy, like easy to understand, and even functionality also very easy. But still you'll get the questions, more questions from this topic. Okay. Now let's get into that one. Shiva, Spark runs on top of cluster, right? Yes. Spark runs on top of cluster. That's okay. Okay. I'll tell you, I'll talk in a normal layman language here. I have 10 people, guys. Or you take software company. Okay. I have a team actually. I have a team. Okay. Team of 10 members in a company, XYZ company. I ask them to do a project. Hey, team, can you implement this project? Will they do directly? Will they do directly? If I ask them to do, will they start doing that one? No, right? No, they don't do that. All are developers only. Consider that all
We
are
have
developers.
leads, managers.
We have to have hierarchy, right? We have to have hierarchy. Okay. So generally in the software industry, you will get the project from the sales team. Okay. Sales team will try directly hand over it to the like your what I can say, your implementation delivery team. Actually, I would say delivery team, delivery side, delivery manager is there. So he will assign like one project manager to that project actually. Okay. This project manager will hand over this one to the leads or architects in the project, and these leads actually will ask developers to do that project. Okay. There is a hierarchy here. Okay. So this hierarchy, I would say this process, we call it as a master slave architecture. Can I call it as a master slave? Because whatever manager and lead is giving instructions to us, to the developers, they are doing it. Whatever the instructions we are getting from the manager or lead, that is what even developers doing or testers are doing. Correct or not? Yes. Now, try to apply same concept in Spark as well. Even I have 10 systems here. Simply, if I ask the cluster to do my task, hey, execute this program, it will not do that one. It doesn't understand what is that. What is that program, and who has to execute that one, how to divide that one. All those things directly does not understand by the Spark cluster. Somebody has to guide that actually, that cluster. Hey, you take this task, you take this task, you take this task, you execute this task, and after that you complete, after completion of this task actually give me that one. Give me the result back. That's what Spark follows here. See, Spark always follows master-slave architecture. Who is the master here? This guy is the master here, and these are all these. Okay, let me erase this one so that you'll understand. Who is the master here? This guy is the master actually. These two guys are the masters, and these guys are actually slaves. Okay, this one we call it as a master node. Master node. Okay, these systems. See, node is nothing but a system ultimately. Node or system or computer, whatever you call it. Terminology is same here. Terminology indicates here it's a computer. It's an like a system, I can say. Okay. Now, these nodes, we call it as actually worker nodes or slave nodes. Slave or worker nodes. This one we call it as a master node. Master node will give the task to slave or worker nodes. Okay. Shiva, what is this? What this guy will do actually? What these guys will do actually? Okay. Now, what we need to understand is whenever we wanted to execute some program, some task, or some work, then what we need to do is we need to hand over that work to the master node actually. Okay. In your project, manager is doing the project, manager is start like writing the code. No, we don't do that one actually. Here also, manager does not execute the program. Manager does not like start processing the data. What he does is, what this manager will do is, here we have a driver program, right? Driver program is a main entry point. Driver program is this guy will accept actually the program from the client. Client means we are the clients actually. From the user, I can say. This guy will accept the program from the user and he will initiate the Spark context or Spark session, I can say. Spark context or Spark session. I can say Spark session. What this Spark context, what does this exactly mean by? Guys, remember one thing. I told you already yesterday in yesterday's class also, when you have a cluster, user does not have direct access to the cluster. You cannot go directly interact with the cluster actually. You can interact only with the master system. That's it. You cannot even touch this one actually. What this guy will do is, when you submit a program here, this system actually has to establish the connection with this particular like cluster, right? That is what this is going to do. Okay, simple example I'll tell you. Okay, see, when you install SSMS or when you install like a SQL Server or your Oracle database or your Snowflake, when you want to execute something actually, what you will do? Let's say I'll try to open my SSMS here. Let's say I have decided to execute some queries case. What you will do? What you will do? Okay, I'm connecting here to the local, to the database actually. Now I have decided to like execute something. What you will do first? What is the first step you do?
Open editor.
Open editor. Okay. Where do you open that editor actually? Okay, let's say I'm trying to right clicking on that one and new query. This is what I'll open. See, my database is installed in my local system actually. And this is just an interface to like interact with my database. What is this doing? The moment you give right click here and say new query here, it is opening one worksheet here. What is that worksheet? It's a session. I told you in Snowflake also, every worksheet will act as a session, and that session is responsible for going and interacting with that database. Did I tell you that? Same thing
Shiva.
here also. When you open a worksheet here, indirectly this worksheet is establishing a connection to your database. It is creating a session. Now, in the same way, if you want to interact with this cluster, okay, you need to create a session. That session will be created by Spark session or the Spark context. Before you do any task, actually, you have to go and contact with the like cluster, right? That is what it is doing here. Okay. Okay. Okay, Shiva. That is okay. Fine. And next. Okay. I've given the program to like let's say I'm trying to execute actually. Hey, find out number of word count in a given file. I have a file actually. In that file, Python is programming language. Scala is also programming language. So Spark is like a very famous like framework for processing a large scale data. Like that, I've written some content in that file. Now, I wanted to find out the word count. How many times Spark repeated, how many times Hadoop repeated, how many times Python repeated. That I wanted to calculate actually. So that is what the program I've written here, and I've handed over it to the driver program. Okay. What this driver program will do? Will it start calculating all those things, counts? Like how many times it has repeated? No. No. What it does is actually, let's say you have given 500 MB of data to the not program, data. So let's say you're reading the data from the HDFS location. You're reading the data from the HDFS location or from your local. Okay, you asked this driver program to like do a word count program on this data, on top of this data, text file, whatever you have on top of that one, you ask that one to do that calculation. Okay, now whenever driver observes that okay 500 MB of data is there in the local, it actually reads the data logically into here, not direct data actually. Okay, 500 MB of data is there. Now what it will do is this will divide this 500 MB of data into blocks or partitions. What is the block size, default block size in Hadoop 1.0, and what is the default block size in the Hadoop 2.0? I told you already yesterday. 64 in the 1.0. Okay. 128 in the 2.0. Still Spark also following the same concept here. Now it will try to divide this 500 MB with 128 MB. Then how many partitions it is going to create on total here on this data on total data? How many partitions? 128 MB block one will be created. 128 MB block will be created. 128 MB block will be created. How much you'll get total here? 8 plus 8 plus 8. 24. 24 plus 8. Sorry, 24, right? Okay, 8. And here 384. 384 minus 500. 72. 72. Correct, right?
Total 4.
Sorry. Okay. Whatever the number it is. Total, it is going to create 4 partitions. Logically, see, it is not going to divide your data physically. Logically, it will try to divide it. How it is dividing, that is none of your business. Spark master will do that. On what basis it is going to do, that's none of our business. So now it has divided the data. That's fine. 4 partitions are there. Now, see, in a cluster, actually, here I've taken example of only 3 nodes here. In a cluster, you may have any number of nodes. Let's consider you have 4 nodes here. You have 4 nodes. Okay. Consider this cluster is already running. Some of the nodes are busy in executing that previous program. Okay. This master does not know which resource is free, and which resource is busy. It doesn't know actually. What it will do is, it will go to the cluster manager. It will ask, hey, cluster manager, I wanted to execute a word count program. Can you give me the resources from the this cluster? Can you give this task to the to the cluster? Actually, this cluster manager is also part of this master only. That is also one of the sub process, I can say. This is one process. This is one sub process. This is one. Both are resides in a master node only. One process is talking to another process now. Sub process. One sub process is talking to another sub process in the same node. Now this will go and talk to this one. Hey, I have 4 partitions actually. Okay, I wanted to execute that. These partitions, okay, 4 partitions got created right here. Okay, I have four partitions actually, which where user asking me to calculate the word count program. User asking me to execute the word count program on top of it. Now, what this cluster manager will do is, it will go and check actually who is free and how much memory, how much RAM, okay, and how much processor, I can say. Processor is nothing but, I told you, right? In every system, actually, we have quad core system and octa core. Most of the systems are quad core systems or octa core systems. Okay, guys, processors, you guys have to talk from now onwards in terms of cores. Okay, if it is a quad core system, quad core means 4 cores. All each core can run independently, can do a task separate independently. That means indirectly what I'm trying to say here is, it is a one core is nothing but one thread. One core is nothing but one thread. If it is a quad core system, your system can do 4 tasks parallelly or independently. 4 threads will be initiated in the backend. If it is a quad core, that means 8 threads will be initiated. 8 processors are there indirectly in the backend. Your processor is divided into 8 parts actually here. 1, 2, 3, 4, 5, 6, 7, 8. Now each thread or each subprocessor can do one task. From now onwards, we don't call it as a processor. We have to call it as a like cores. Let's say my system is actually 8 core system or octa core system. 8 is nothing but octa core system. Okay. Now for completing this task, actually, now I have to allocate like 2 cores for this. 2 core. Okay. How much RAM memory is required? How many cores are required here? That is what it is going to calculate here actually. Or if you give that like configuration, it is going to get this resources accordingly. Or if you don't give anything, it will go and get default configuration is it. As per the default configuration, it will go and check here from each and every worker node. See, what it will do is, I told you, right? Total 4 partitions, 4 systems are there. Now, anyway, here my 4 partitions are there here. Now, what this cluster manager will do is, it will go and tell to this particular worker node, hey, I have a partition, that is partition P1. Okay, I have partition P2, I have partition P3, and I have partition P4. Hey, hey executor, This one we call it as executor, guys. Like I'll tell you the terminology bit later. Okay, for now, you call it as a worker node only. It will come to this worker node and it will say that, hey, I have partition P1. I've created a task for you and you try to execute that. Okay, and this cluster manager, whatever the program you have written, right, that program and this partition, both it will try to hand over to this one. Execute this. Okay, now it will go and talk to this one also. Hey, I have partition 2 and I have a word count program. You take that one and try to execute that. Now partition 3 will be given to this one, partition 4 will be given to this one. Now equally distributed here. All 4 partitions are equally distributed here. I mean, there is no guarantee that the partitions will be like distributed equally here. That depends on the process actually. See, just since we are understanding it first time here, we are I'm equally distributing or I'm giving I'm handovering that particular job to everyone here. But in reality, there is no guarantee that all 4 partitions will be executed by all 4 systems. It can be executed only by 2 systems. It can be executed by 3 systems also. It can be executed by only one system also. I mean, how big configuration it has, depending on that actually, depending on the resources, I can say. But for now, you try to understand all these partitions are handed over to the what this cluster manager will do is it will try to create a task for that partition. Task 1, task 2, task 3, task 4. 4 tasks are there, or all 4 tasks has given to all 4 worker nodes. That means if I have 40 lines of text here, 10 lines are given to this one, 10 lines are given to this one, 10 lines are given to this one, 10 lines are given to this one. Now, my processor actually, see, program also, see, wherever your data is there, program will go there actually. Program will go to that system. Wherever your data is residing, your program will go and sit there. Your program will go and execute that data, execute on top of that data. Okay. Now, what it will do is, it will take this partition into RAM memory, guys, here. Whatever the partition it has created, right, divided right here, let's say 128 MB block, right, that 128 MB actually will be taken into RAM memory of the RAM memory of the worker node 1. Similarly, other ones also. RAM memory, and remaining data will sit in a RAM memory. Now the computation will start from here. Computation will start. Okay. Here, Python is repeated to 2 times. Hadoop is repeated to 10 times. Okay. Let's say, word count, I'm trying to say. Okay. Hadoop word actually repeated 10 times. Now here also, let's say Python is repeated 10 times and Hadoop is repeated 5 times. And here also is repeated, okay, 2 times. Hadoop is repeated 2 times. Like that, everywhere it is calculated. Now, workers actually calculated. But I want overall count, right? How many times actually Python repeated? How many times actually Hadoop repeated? How many times actually program word repeated? How many times is repeated? Like that, I want everything right here. Okay. Now, this executor, after calculating this one, this will go and hand over everything to your driver program directly to this one. Okay, this will come back and give that data here. This will come back and give the data here. And this will come back and give the data result here. And this driver program combines the data and it gives back to the user. That is the execution flow. Did I make it clumsy by drawing all these things here?
No, sure.
Now you understood the use of each and everything here.
Yes.
Okay. I'm repeating guys here. The moment you submit your program, word count program or anything, it can be anything. It can be anything. Or finding out the highest salary on employee table, or deleting the duplicates, or finding out the distinct values, whatever requirement it is, whatever the requirement it is. Okay, you first give it to the driver program. Driver will not execute your program actually. Driver will not execute your program. Driver will not will actually initiate your task. What driver will do is driver will try to divide first your data into partitions, like P1, P2, and so on like that. And after that, it will try to create the task on top of it. T1, T2, okay, T3, like that. It will try to divide. Okay, and after that, it will go to the cluster manager. Hey, I have 4 tasks actually. I need a resources from the cluster to execute my partitions or tasks. Please arrange me that, and hand over these tasks to that executors. Okay, then what cluster manager will do is it will go and check the availability of the each resource in the worker node, how much RAM is required to execute this particular task, how many cores are required to execute this particular task. It will go and check that one. And if the resources are available, it will actually hand over this particular task to each and every worker node. After and along with the program, okay, and after execution, actually, the result will be handed over back to the driver program, and the driver will driver will display results back to the user. Forward direction, backward direction. See. Okay, guys, this is at high level. So I have concept actually, yarn concept is there, that I'll take special class for this one actually to explain the functionality of this Spark backend terminology and execution. Okay, in that class I'll explain very neatly. I'll explain this one like a story. For now, at high level, you just try to understand this is the execution flow. That's it. Okay, see these mesos, yarn, all these are actually cluster managers. Kubernetes is also one of the cluster manager. All these guys actually cluster manage. These guys actually manages the cluster. These guys will go and talk to the worker nodes or slaves. Okay. Huh. We understood, Siva. That is fine. Okay. Now I'll tell you one thing here. Where is that Python and all? 1 second. Siva, you mentioned Spark actually built on top of Scala language, right? Scala again built on top of Java. Ultimately, Spark is running in Java only. Ultimately, not directly, indirectly, it is running on a Java. Okay, so Spark built using Scala language actually. See, guys, in 2015, 16, 17, 18, up to 2020, I can say. Okay, 2015, after 15, you know what happened? Most of the companies actually they started using Scala language for processing their data. For processing their data. Okay. Most of the companies, I can say. Whoever is using Spark language, they started using Scala language for interacting, for processing their data. At that time, actually, even Python was also extensively used by these data scientists. And that too, for the data scientists, actually, they need to process huge volume of the data and they need to run actually these iterative algorithms and all, right? Iteratively run their algorithms right here. So they are very good in Python. They are very good in Python. They're not good in Scala. Then what happened, you can interact to the Spark using Python language as well. Python interface also, like using Python language also, you can interact with the Spark execution engine, I can say. Not only Scala, Python is also one of the language to interact with the Spark. Python is just a interface language, guys, to talk to your Spark. You know what happened? 80% of the companies actually they were using after 2016 and 17. They started Scala. They used Scala as a programming language to run their to process their data. And 20% of the companies actually they started using like Python as a interface language to talk to the Spark. Now, after this data science has become very popular, or people started using Python extensively, then what happened? This ratio got reversed. Most of the companies started switching completely to Python from Scala. Why, Why, If you want to like stick to the Scala, if you want to like go with the Scala language, along with the Python language, again, you have to learn the Scala language. Of course, it is easy one. Of course, you have to learn it, right? You have to implement it, right? So, why to learn Scala separately? We already have Python to interact with Spark. Why don't we use the Python language for to interact with the Spark? Then people started like using Python as extensively to interact with the Spark. Okay, and one more like advantage I'll tell you, like using Python language compared to the Scala language. Scala built actually on top of Java language, right? On top of Java language, right? Okay, if you want to like execute some program in like in Spark, right? In Spark, actually, in Java, actually, if you want to execute something, you have to build jars, right? You have to build a jar file, right? Correct or not? People who are from Java background, you correct me if I'm wrong. You have to build the Java jar files actually to make it executable file. Correct or not? Yes. So in order to build this jar file, again we have to use build tools. Maven or Ant or like some tools are there in the market. You have to use all those tools. But if you use Python language, actually, you don't need to use all these things. You don't need to build like these class files. You don't need to build these jar files, and you don't need to use Maven, like and all those things. If you use Python language, just write your code in a file. Okay, you just try to save that file in a with the .py file, and you start like submit that to the Spark. That's it. Let's consider you have a Spark engine here. If you want to execute your program, you have to build the jar file and you have to submit to the Spark engine actually, so that your Spark engine will execute this jar file. But what about the Python? Python also has jar concept. No, it's a Java one actually. Even in Scala also you have to build the jar files. But when you use Python language, actually, you don't need to build all the jar files and all. You just simply write your code in and save it with .py and directly submit that code to the Spark. It will interact. It will execute that. Ultimately, what will happen? Even if you submit your code in Python language, backend it will try to convert that into Java language only, because Your Spark actually built on top of Scala, right? Scala built on top of Java, right? Ultimately, your Python objects also will be eventually converted into Java objects. Java, I'm not saying Java language, Java objects. Python objects will be converted into Java objects. Ultimately. That is what my first point. No need to compile. You don't need to compile the Python files actually. And you don't need to have dependency. See, in Java, actually, you need to set the dependencies on the external packages, guys. That's very headache, actually. That was really headache. You need to download the jar files from the Maven repository from the online, and you need to like download into your local, or you need to put that one in some external location, and you need to you need to tell to Scala to go and interact with that one. You have to do all those things. You have to set the dependencies. But in Python, you don't need to do all these things. That is the biggest advantage with the Python. And that too, Python, Python is very easy language. If you know English language, Python is damn easy, I can say. For loop, if loop, you already have gone through that, right? Like those are plain English language only, right? Hardly 38 keywords are there in your Python. That's it. 38 keywords. That's it. If you're mastering on all those keywords, that's it. You're good. So less coding overhead. And it is very easy, of course. And you might already know Python. Data science people already know Python. Again, why they have to learn the Java, like a Scala and all? That's a time consuming. Okay. And Python has huge community and powerful libraries. Python has lakhs of libraries, guys. Lakhs of libraries. And it has very big community. You know what is the advantage of this community? If you get into any issues, actually, if you go and post it in a community group, actually, if any other person actually face that problem, they can able to answer, they can able to give the solution to that problem. That is the biggest advantage with the community. Python has very good community compared to the Scala. More programmers are there compared to Scala. So ultimately, what industry thought was, why to focus on the other language, new language? Let's try to focus on the existing language only, that is Python only, and let's use that one. Okay, but 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 Scala is a ultimate choice case actually to talk to Spark. Why I'm telling that point is, see, when you try to interact with Python, right? Again, Python objects has to be converted into Java objects. Those Java objects will be executed in the Spark engine, right? So converting these Python objects into Java objects is a like again, it will take some time actually. It will take some time. If you write directly in Scala, Scala built on top of Java. Already Java objects are getting created indirectly there. Then you don't need to convert anything. So performance point of view, if you compare Python and Scala will give more performance actually. If you write your code in Scala, the execution will be bit faster compared to the Python. Okay, and one more advantage is, any new features are launched in like Spark, right? First, they'll be launched in Scala language only. Scala new features will be available only in the Scala language. Later, after some point of time, they will be available for PySpark people. Okay. See, we used to have that difference, guys. Now, actually, You use PySpark or a Scala Spark, anything is okay. You will not get much performance difference. 1 or 2%, of course, Scala is a will give more compared to PySpark will give more performance. Of course, minor percentage only, not that much great difference. If Scala is giving completely more performance than PySpark, people would have chosen like Scala language, right, by this time. Since there is no much performance difference between these two languages, people started shifting towards the PySpark. But what I'm telling is, if you become a master in PySpark, you're already mastering in Scala indirectly. The APIs are same as it is, guys. You will not feel the difference. You will not even identify the differences also. Almost all the comments are same. If you become a master in Python and PySpark, indirectly you are a master in Scala. Okay. Now tell me, if I want to install Spark in my local, what are all the things are required here? Come on, tell me. With your knowledge, you tell me. If you really understood all these concepts, you tell me what are all the things are required. I mean, which languages are required here? No, tell me.
Java and Scala.
Scala we don't need to install because when you download that one, actually you'll get it automatically by default inbuilt. What else?
Java.
Of course, Java is required. I told you, right? Scala is built on top of Java only, right? So backend it has to execute in Java only indirectly. So in your local system or in wherever you're installing that Spark, you need to have Java. Now you understood why we have to install Java in our local? Yes. Of course, if you are using Python, PySpark, actually, you need Python as well. Python will go and interact with Java indirectly here. Okay. Now let me tell you here. Okay. You'll understand here so that it will be easy. This is the architecture of the PySpark, guys, actually. Not Spark, PySpark, I would say. Now I'll tell you one new point here. What will happen is, this is Spark context. When you submit a job, to the master or a Spark driver, then backend it will go and establish the connection with the cluster. Okay, it has established. Actually. Now you have written your code actually in Java. I mean, in your Python language, right? But cluster will not understand directly that Python language, right? Somebody has to there in between Java and Python to convert those objects, Python objects, into Java objects, right? Now, who is that fellow here? Can anybody guess it? Who is that fellow here? Can anybody guess it? Here.
Yes.
Sorry?
PY4J for context.
What is this? Anybody know full form of this? Python for Java. PY, Python. 4 means for. J means Java. Python for Java. What this guy will do actually? This guy will convert. See, by default, it will be convert. By default, in Python, actually, it will be serialized. It will be converted into your objects. Those objects will be converted into Java objects, and it will be handed over to the executors, to the cluster, I can say. This master node will try to hand over that objects to the executors. That is the reason we got 5.4G here. Okay, that Python RDD will be handed over to this one. Now, try to understand one thing here. This is one worker node, worker node, worker node. Inside that one, actually, I have written small, I mean, I have drawn some small boxes also here. What is this actually? Executor. What is this executor means? Let's consider my system, this executor, this worker node has 64 GB of memory, RAM, I can say. Memory means RAM. From now onwards, we'll deal with RAM memory only, guys. Now, RAM has become a superhero now. RAM has become a superhero in Spark. Because everything is processed by RAM, not by the disk, hard disk. Of course, hard disk also we use, not for regularly, not regularly. But mostly 99% of the cases we use RAM only. Consider my worker node has 64 GB and it has 8 cores. 8 cores, octa-core system. This is the configuration of each worker node. Okay, what they will do, what they will do, they will try to, instead of like submitting your entire job directly to this one, they will try to divide this into 4 parts. 4 parts means if you divide this RAM memory into 4 parts, how much each executor you'll get memory here? You'll get how much each executor memory you'll get here? 64 divided by 4, guys. 16 GB, yeah? Yes. Did I ask difficult question? I don't know. Okay.
Yes, sure, 16.
16. 64 divided by 4 is 16 GB and 8 cores, 8 divided by 4 equal to 2 cores. Okay. This one, I call it as one container. Container is nothing but I can call it as a executor. See, if 2 cores and 16 GB memory can be done, if this can be done, one task can be done by this one, I'll try to divide my worker node into different executors. See, ultimately, depending on the memory, they'll try to divide it. There is no guarantee that in your worker node, you'll be having only 4 executors. You can have any number of executors. That depends on your configuration, Spark configuration in the backend. Remember that point. So this I did not discuss in the Spark architecture. See, one worker node can have any number of executors. Your task, whatever it's divided right here, task 1, task 2, task 3 are the right. Your tasks are actually executed by this executor, not by the worker. I mean, not by the entire worker node. This task will be executed by the executor. That is the reason why I told you all these 4 tasks either can be executed by all worker nodes or can be executed by only one worker node. Why did I tell you that point? This task 2 can be handed out to this executor. Task 3 will be handed out to this one. Task 4 can be handed out to the this one. That depending on whether they are free or busy. Who will decide that one? Your task manager is there, right? The task manager will decide whether to hand over all these tasks to the single worker node or multiple worker nodes. If really this executor is busy, then 4th task will be handed out to this one or this one. So remember the point here. Your worker node internally can have containers. Each container we call it as a executor. Container is nothing but a logically I am dividing the resources, guys, here. That's it. See, ultimately in this worker node, you have 64 GB, 8 cores only. Logically, I'm trying to divide that one. If you're executing this particular task, only 16 GB memory and 2 cores will be allocated to this. 16 GB, 2 cores, 16 GB, 2 cores, 16 GB, 2 cores. Equally distributed here. If we have 120 GB, 128 GB of RAM, as per that, it will try to divide it. Clear here? Okay, now these are all the components of the Spark case. This is the last slide I'm going to discuss today. Uh, hmm. I told you Spark can interact with Hadoop. Spark can process JSON files. Spark can interact with the AWS. Spark can interact with the HBase. That is also one of the NoSQL databases in Hadoop. You don't need to worry about this one. No, like very less companies are using this one now. Okay. Spark can interact with the MySQL. Spark can interact with the Elasticsearch in AWS. Spark can interact with your local as well, local memory as well. All these are memories, I can say. HDFS, JSON, these are files actually. And Amazon S3, Spark can interact with the NoSQL database. Spark can interact with this database as well. Spark can interact with the service as well. Spark is just a pluggable plug and play language, guys, I can say. Plug and play framework, I can say. Compute engine, I can say. You can connect to any of these systems, I can say. Okay, in Spark, actually, we have very good rich API, data source APIs, actually. Okay, we have mainly two categories are there, guys, here. Spark core and data frames. From tomorrow onwards, we are going to discuss about the Spark core. On top of the Spark core, actually, data frames are built. So this will take alone like 1 week to 6 days, 1 week of time. And after that, I'm going to start this data frame. This is actually your actual Spark. Okay, these data frames can process batch data. They can process your streaming data. They can process your machine learning libraries. They can process your graphics libraries, and they can even interact with the third-party libraries as well. These data frames, whatever we are going to discuss. Okay, and you can write these data frames in Python language, or in Java language, or in R language, or in Scala language. The preferable one is Python one. I mean, of course, some companies still, if you go and check in the LinkedIn, they'll ask this Scala experience also. See, I'm not saying that Scala will go away from the market. No, it will not go away. Still, people will use Scala only, but percentage is less. That's it. Anyway, Python is there. That too easy. Many people can focus easily on this one. So most of the companies prefer to use Python. Okay, Java very less, I can say. So if I give the ratio here, out of 100%, I can say 70 to 80% of the companies actually using Python language. Okay, in remaining 20 to 30%, okay, Scala is being used 15 to 20 to 25%. Remaining 5% actually, not even 5%, I can say 2 to 3% of the companies using Java and R. That's it, only 2 to 3%. So my recommendation is you go with the Python only. So these are all the core components of the Spark, I would say. So mainly we are going to discuss about the Spark core and the data frames. Data frames are nothing but Spark SQL part. Okay, so what you guys will do is tomorrow onwards, I'll try to execute the codes. Okay, today I already started that this one execution part. So I'll give you the, I mean, I'll give you one document how to install the Spark in your local. Guys, if you have like what I can say, like Python, sorry, Databricks Community Edition. See, to execute all these things, actually, you can create like a Databricks community edition. You go to the Databricks like a website and try to. Databricks is also a Spark company only, right? Spark co-founder only, he came out and he started the Databricks company. Okay, and they have community edition actually. There also you can execute all these commands, whatever I'm going to explain from tomorrow. Or if you want to execute all these commands in your local, please try to install Spark. Okay, I'll give you a document. I'll walk you through that one. Just a second. PySpark installation. I'll give this installation document very clearly. I mentioned here everything, how to install and how to check all those things. I've given everything step by step here. So please try to follow my steps like one by one. Don't use your intelligence. Please follow my steps carefully so that you can install it very easily. You can complete the installation without any errors if you follow my instructions. Or if you want to follow some YouTube videos and all, you can follow, but recommended one is this one only. Okay. So what did I do here is, one second. Sorry, one second. Oh. So what did I use? What we have to do is, if at all if you want to install Spark in your local, you have to install Java first. That is mandatory because Spark is running on top of Java, right? Actually, indirectly. So you have to install Java. So for that Java version also, link also I've given here. Okay, for installing that Java. If you don't have that, okay, you can download directly from. I have given the link here. You can directly download that and try to install that one. So try to install 64-bit, guys. If your system is 32-bit, you try to install 32-bit. Most of the systems now 64-bit systems only. So you try to install 64-bit Java. Please try to follow instructions here. Okay. And next, check Java is installed properly or not. After that, you need to install 7-zip software in your system. Why I'm asking you to install the 7-zip is, when you try to download Spark software from the Apache website, it will extension is actually GIF. The Spark installation extension is GIF files actually. You need to unzip them. So the best software to unzip that particular file is 7-zip. You already have WinRAR, that is okay. If you don't have WinRAR WinZip software, you try to install 7-zip. This is an open source one. This is also okay. Try to download this one also from the. I think I've given the link here. One second. One second. I think I've given already that. Did I not given that one? Or anyway, you try to directly search it in Google so that you will get it directly. That is also okay. Okay. And after that, third step, what we need to do is, you already have installed Python, right? Python, don't install it separately. Don't go to the Python website and try to install 3.10, 3.8, 3.9 and all those things. You already installed Anaconda, which I've given last week. That is enough actually. You don't install this Python separately, please. That will mess up the things actually. I'm telling you, I'm warning you. Please do not install Python separately. Standalone Python is not required here. When you install Anaconda, by default, Python will get installed. Whatever the software I've given. That software has Python 3.8, which is a stable version. Okay, so I've given step here. Third step you can ignore. If you have already installed that Anaconda. Third step, please ignore. Okay. And since you're installing Anaconda here, you need to run these commands as well, because Anaconda has to understand where is that Spark installed and all. Okay. Okay. And after that, you need to install Apache Spark. There is no installation of Apache Spark software, guys. This is just a configuration. That's it. You need to install only Java and Anaconda. That's it. Only these two softwares you have to install. Remaining everything is a configuration. That's it. What you need to do is you need to configure. You need to download the Apache Spark latest file from the download page in the Apache Spark website, official website, guys. See, whatever I mentioned in this document, everything I'm recommending you to download everything from the official websites only. Do not download any software from the third-party websites. And don't ask me, I got virus because of you only. Don't tell me that, please. Okay, so when you go to the Apache website, right, it will ask you to install this one. Better you try to install 3.4.1 version, or any latest is there, you try to take that one also, no problem. Or you take 3. It's a stable version. If you want, you can take this one, or you better take better take this version, or latest also. Anything is okay. Okay, and after that, there is no installation part, guys. You just need to configure here. In your local, actually, you need to create a folder called Spark Setup. See how I have done that one in my local. The same way you have to do it. So in your C drive, you try to do that. Okay. See here, Spark Setup. So here you need to unzip that one and you need to configure a little bit. Okay, the star file is there. This is the file actually will get downloaded from the Apache website. You need to right click this one using 7-zip. You need to extract that so that you will get this file. Okay, I've given here. If you don't get it, please like ask me tomorrow. I'll try to show you practically. I'll try to uninstall everything from in my system. I'll try to show you everything. That's okay. Okay, and you need to follow these steps. And you need to install WinUtils as well. Windows utilities. Okay, indirectly, it is this WinUtils will give you Hadoop kind of environment. Indirectly, this utils. Okay. And follow these steps directly. You'll be installing it properly. Okay. I'll give this document to you. I'll share this document with you. Okay. Yeah. That's all, guys. Any questions?
Like Hadoop, are we going to store 3 copies of data in Spark as well?
Same thing. Same concept. Replication factor is 3 only here also. Okay, so tomorrow onwards, no more theory classes. Only practicals will start. Because to understand all these things, I have to discuss the theory part, guys. Otherwise, you will not understand anything. Okay, so this is also one of the entry question. What is the difference between MapReduce and Spark? And how like Spark executes? Is it a in-memory execution model or some other execution model? They will ask that. Okay.